Hi, my name's Carolyn, and we're going to be talking about the role of gas exchange in respiration. Looking at this table, you will see four of the gases that are regularly circulating from atmospheric air into our bodies. We will be focusing on the middle two rows, on oxygen and carbon dioxide. This table tells us pressures and partial pressures of gases in the atmosphere and in the alveoli of our lungs, meaning that this represents pulmonary ventilation. You might be surprised to see that there is more carbon dioxide in our alveoli than in the atmosphere, and likewise less oxygen in our lungs than in the atmosphere. Around me, atmospheric pressure is 760 millimeters of mercury, and in here, alveolar pressure is 756 millimeters of mercury. So ultimately, we will see gases move down their pressure gradient into the alveoli, where there's more room for them upon inflation of the lungs. Now we're going to split everything up and look at Dalton's law of partial pressures. This law states that in a gaseous mixture, each gas acts independently and exerts its own partial pressures. This is ultimately how carbon dioxide and oxygen move as we need them to. This diagram exemplifies Dalton's law in relation to gas exchange in pulmonary ventilation and external and internal respiration. From the top right-hand corner in the alveoli, note the huge jump oxygen takes down its pressure gradient as it replenishes tissue stores from freshly oxygenated blood. Carbon dioxide inversely moves out of the tissue cells back into the bloodstream. Let's look at solubility of gases. I'd like to look at an element of Henry's law. Marib and Hearn tell us that when a gas is in contact with a liquid, that gas will dissolve in the liquid in proportion to its partial pressure. But there's also solubility. Nitrogen isn't very soluble at sea level, and despite its huge constituent in our body, has no effect to speak of. Carbon dioxide is more soluble than oxygen, despite oxygen's lower molecular weight, and so diffusion of carbon dioxide occurs most rapidly. Tortora and Derrickson note that when diffusion is slower than normal, for example in emphysema or pulmonary edema, hypoxia typically occurs before hypercapnia. There is a huge surface area available for gas exchange in the grape-like alveoli. It is 70 meters squared and the lungs are famously elastic. This is particularly compromised in emphysema, where there is a destruction of alveolar walls, among other things. Lung volume reduction surgery is a fairly recent and rare surgical option for sufferers. Emphysema is often caused by smoking, but a 20-year study has shown no significant risk for casual smokers of marijuana. Thanks for watching this video about gas exchange.